Please start.
Yeah. So very good morning to everybody and welcome you all to the 30th webinar of Plan Reading webinar series. These webinars are being organized by the Foundation for Advanced Training in Plan Reading on a monthly basis. And today we have Dr. Chandish R. Ballal, who will talk about can significant bugs save the planet? The purpose of these webinars are to sensitize people to know and value the importance of plan reading and also to create an awareness on various aspects like technology integration, policy support, regulatory overview, farmers' comprehensions, and various other aspects required for inclusive development of crop improvement. Foundation for Advanced Training in Plant Breeding, abbreviated as ATPBR, is a non-profit organization which dedicates to enhance capacity building in agriculture, particularly in the field of plant breeding. With its global reach and collaborative platform, ATPBR stands at the front of fostering personal and institutional capabilities in alignment with current and future agriculture need. We are committed to formulate strategies that contribute to effective crop improvement program and the development of human skills essential for ensuring sustainability in agriculture. The main objective of this foundation are to develop sustainable agriculture R&D system to serve farmers, support emerging entrepreneurs through advanced research and training, and assist seed industry to build market-driven competencies in human resource and make crop improvement an attractive and profitable business. ATPBR organizes professional training, monthly webinars, national and global conference, and support publication. So far, we have organized 5 national conference, 1 global conference, 27 professional training, 30 webinars, and reach more than 12,000 students and professionals representing agrarian community. Under the aegis of ATPBR, we have published 5 books, where book on market-driven plant breeding for practicing breeders, published in collaboration with Springer, is our flagship publication. We have trained professionals from 66 organizations spread across India, Sri Lanka, Bangladesh, Brazil, Italy, Nepal, Afghanistan, Nigeria, Kenya, Vietnam, Thailand, and still the list is increasing. We have 12A ATG CSR certification as well, and we are eligible for conducting any CSR project for the industry. Now, I would like to take a privilege to introduce our moderator, Dr. Sharan Angari. He is the plant geneticist and breeder who worked for 17 years for public sector and 22 years with the private sector. He worked with Nunem Seeds, Netherlands, where he served as head of breeding for Asia Pacific and global coordinator for pepper, spanning several countries in Asia, Europe, and America. After his retirement, he continued to provide his excellent R&D advice to seed companies in India and abroad, besides serving on various aspects of expert bodies. Recently, the EPSA has honored him with the most influential plant breeding researcher for horticultural crop award year 2021. It's a privilege and honor to have you here, sir. I request Sharan sir to please take the floor.
Good morning, Dr. Chandish, and good morning, everyone. And thanks, Dr. Aparna, for those few introductory remarks. As many of us know, Dr. Chandish is an excellent speaker. That's why you see a lot of registrations for this. And I'm glad we are starting this new year with our talk. So wish you all a very happy new year. And just to give a few introductory things, I was slightly curious to know about our topic. The word bugs in the title of our talk, can insignificant bugs save the planet? That aroused my curiosity. The multiple meanings of the word like glitch, sickness, to annoy, etc. bugged me. I thought of computer bugs and secret installations of listening devices. Wondering about her choice, I did some research. Here is what I found on the etymology of the word bug. Incidentally, Entomology, the field of Dr. Chandi's expertise. The word bug first shows up in the earliest English translation of the complete Bible. It then meant a hobgoblin or scarecrow. It was in the 17th century that bug was used to describe insects. The first insect linked with the word was the bothersome bedbug that quietly feeds on people at night as if they had been visited by a hobgoblin. Later in the 18th century, the taxonomist Carl Linnaeus system, insects that became grouped in the same order as bedbugs were called true bugs. That's what I found about the meaning of the bugs. And I would like to start with an anecdote attributed to Charles Darwin, the British biologist and naturalist, best known for his theory of evolution for natural selection. Before you go to the main anecdote, here is the starter. How did Darwin propose to his wife? The answer is he said that she was his natural selection. A person specialized in natural selection said that. Now, the anecdote. Two English boys, friends of Darwin, wanted to play a joke on him. They caught a butterfly, a grasshopper, a beetle, and a centipede, and they made a strange composite insect. They took the centipede's body, the butterfly's wings, the grasshopper's legs, and the beetle's head, and they glued them together carefully and took their creation to Darwin. We caught this bug in a field, they said. Can you tell us what kind of bug it is, sir? Darwin looked at the bug and then he looked at the boys. He smiled slightly. Did it hum when you caught it? He asked. Yes, they answered, nudging one another. Then said Darwin, it is a humbug. You know, humbug meaning nonsense. With that, I now come to my main task of introducing Dr. Chandish Ballal. Dr. Chandish Ballal, formerly Director of ICAR, National Bureau of Agricultural Insect Resources, in short NBAIR, India, and Project Coordinator of All India Coordinate Project on Biological Control, has worked extensively on conservation of biodiversity and biological control. She has standardized continuous and effective production technologies for beneficial insects that are being widely adopted by commercial units, researchers, and students. She was holding the largest live insect repository in Asia with 130 different insect cultures that are being maintained continuously. The prompt and continuous supply of quality live insect cultures made and production protocols developed by her continue to be valuable services to the student community, biocontrol researchers, and commercial insectaries. By interacting and conducting demonstration trials in farmers' fields, you could instill confidence in them on the non-chemical mode of pest management. She has handled around 40 research projects and has more than 300 research publications to her credit. Dr. Chandish has received several prestigious awards and recognitions for her seminal contributions to biodiversity and biological control. To mention a few, Professor T.N. Ananthakrishnan Award 2006, the ICR Punjab Rao Deshmukh Outstanding Women Agricultural Scientist Award 2015, Dr. S.P. Singh Biocontrol Lifetime Achievement Award 2016, Dr. S. Pradhan Memorial Award 2018 from IIRI New Delhi, Dr. Ms. Prem Dureja Endowment Award from National Academy of Agriculture Sciences for the biennium 2017 and 18, Dr. B.V. David Lifetime Achievement Award 2019, T.B. Fletcher Memorial Award 2021, and Karnataka Women Achievers Award 2022 for excellence in agriculture. The list is long, I can go on, but these are the ones which I thought I will just mention. As an effective leader of her organization, she has made extensive efforts to strengthen national and international networking to step up taxonomic and biocontrol research in India. After superannuating from ICAR, Dr. Ballal continues to be an active member of research advisory committees of Indian Council of Agricultural Research, Central Silk Board, and Department of Biotechnology, Government of India. This is about Dr. Chandish. With that, Dr. Chandish, my floor is yours. Please take over.
Thank you so much, Dr. Angadi, for the very kind introduction. Thank you, Aparna, for all the coordination. Let me share the slide. Are you able to see the presentation and hear me? Aparna?
Presentation, yes, we can
Yeah.
see your presentation and hear you well. Just click
Okay.
on the hide button. So
Yeah,
this will-
sure. Yeah. Okay. First and foremost, I'm extremely honored that ATPBR, which generally focuses on plant breeding, and an organization of elite plant breeders and geneticists, I have been invited to deliver a talk which is focused more on entomology. And thank you so much for this honor. So the title reads, Can Insignificant Bugs Save the Planet? Very interesting anecdote Dr. Angadi narrated. In fact, in entomology, if you say bugs, they come under a specific order, which is Hemiptera. But then here in this title, I just have considered insects in general when I say bugs. So I would like to start my presentation with a slide on Dr. Edward O. Wilson. He was known as the father of biodiversity and Darwin's natural heir. And this title, which I have chosen for my presentation, was inspired by Dr. Wilson's paper, The Little Things That Run the World, The Importance and Conservation of Invertebrates, which was published in the journal Conservation Biology. In fact, he has focused on all the invertebrates here, including insects. He says, when 42,580 vertebrate species were described, nearly 990,000 invertebrates, which we consider as insignificant, they were described, which consisted of 290,000 beetles. Now, these invertebrates are abundant and diverse due to various factors, which is their small size, the very small niches they occupy because of their body mass, and because of the little domains that they occupy, and the fact that even specialists can coexist in the case of invertebrates. And of course, you all know that insects are part of invertebrates, one of the invertebrates. And he very interestingly says that if invertebrates disappear from the universe, all other life forms will also disappear. But then the reverse is not true. And invertebrates and insects in general continue to be an endless source of scientific exploration for all researchers. But the sad fact is that they are prone to extinction, in spite of the fact that he says an ant is more wonderful than a rhino, which is a huge living organism. Now, I have divided my presentation into 3 parts. The first part is on the role of these insignificant bugs, wherein I would like to give certain facts for you all to decide whether they are really insignificant or are they significant. The second part of my presentation is on, are we losing these insignificant/significant bugs? And the third part, if we are losing them, how are we going to save them? First, let us look at the contribution of insects to biodiversity in general. We know that insects have existed for like 400 million years. They account for a large percentage of the known species in the universe. Now, if we look at the number of species, there are more than 1 million species of insects. But if we take the number of insects, it's more than 10 quintillion. And very interestingly, they say 150 to 1,500 kgs of insects are there for each human being. So you can imagine the quantum of insects which exists. Now, Earth is supposed to harbor, you can see the huge number here, which definitely I cannot read, with so many ants. And this quantum of ants weigh more than all the wild birds and mammals put together. And here is a plate which is very interesting. Now, this plate is showing all the different living organisms. Now, the relative sizes of each organism indicates the number of species in each group. And you can clearly see that the butterfly, which is denoting the insect group, is occupying the largest size, and then that indicates the number of species of insects far outnumber all other life forms put together. Now, what are the services provided by insects? Services or disservices? Now, we all are concerned about the damage caused by insects to agriculture, to household, because we know of several household pests too. Now, because we keep looking at insects as pests, we ignore their ecological importance, but I would like to emphasize that only 0.5% of the total number of known insect species are actually pests. Now, insects play a very important role in ecosystem services as either pollinators or as decomposers or as parasitoids and predators. And this service which they provide through various kinds of services definitely outweighs their pest status. Now, about parasitoids and predators, I'll talk as we talk about biological control. Now, ecosystem services, we can divide them into 4 categories. The first one is the provisioning service, which is the provision of food and other resources to other living organisms. Regulating service is that service which regulates the environment. Biological control comes under that service. Supporting service is a service which underpins all the other ecosystem services, which means it is important for the functioning of the other ecosystem services. And cultural service is the non-material benefit, that is recreation, spiritual, aesthetic value of insects. Now, the most important factor in ecosystem service is that it is provided with no cost, that you are not paying anything when you are benefited by ecosystem services. And the value of ecosystem service is very difficult to calculate. Now, the global value of ecosystem services in US, they have tried to calculate, which may not be accurate. It is estimated at approximately $33 trillion annually. Now, what are the ecosystem disservices? Pests, agriculture or household pests, litter, the biological hazards like diseases caused in human beings and animals because of insects, the allergies which are caused by insects, and even some poisonous organisms. But then I would like to mention here, majority of the cases, the disservices are caused by management practices, wrong management practices like deforestation, example, or concentration of agriculture crops. Now, the annual value of ecological service, they have calculated as more than $57 billion, in which they say dung burial, which is done by insects, is around $0.38 billion. Pollination is about $3.07 billion, and pest control through non-chemical modes, that is insects when they are doing pest control, that is around, the benefit is around $4.49 billion. Now, first I'll speak a bit about the provisioning services by insects. That is, I said, when they provide food and other resources. Now, insects are very critical resources for fish and wildlife as food. And insects also provide honey for human use. And very interestingly, there are a number of species of insects which are edible. And 1,500 species have been recorded. There are many more. And 3,000 ethnic groups in 113 countries, they consume insects. Now, grasshopper protein, grasshoppers, they are harvested in some countries for edible purposes. And it is reported that they can replace vertebrate protein. And the additional advantage is that if grasshopper protein is used, there would be significant reduction in greenhouse gas emissions, and the grain required for livestock production, they can reduce, This can lead to increased grain availability for human consumption. Now, the harvesting of grasshoppers is done in Mexico, where the revenue earned per family is around $3,000. There are medical benefits also through insects. For example, the blowfly maggot, the plate is here of the maggot, that is the Lucilla species, is used for wound healing. And silk and dye are also insect products which are very useful for human beings. Now, what are the supporting services? I mentioned supporting services underpin all the other services. Example, pollination, decomposition, seed dispersal, etc. Now, pollination is something which is very widely recognized because a lot of entomologists work on pollination. And I think almost all the branches of research acknowledge and appreciate the pollination services provided by insects, because 2/3 of all the plant species rely on insects for pollination. Now, there are different kinds of insects who are responsible for pollination, like the bees, the beetles, the butterflies, the flies. Now, the most important fact is that they are necessary for pollination for up to 60 to 90% of the plant species. And there are papers which clearly say that they are critical to 35% of the global crop production. Now, when we speak of herbivory, we are concerned because herbivory is actually when insects start feeding on the plants. But then there is a benefit in herbivory too, because herbivores, when they feed, they maintain the production near carrying capacity. That is, the herbivore diversity and herbivory, the process of herbivory is related to the plant diversity. I'll just tell you how. Usually pest outbreaks occur when there are some changes, drastic changes in environment, and there are some conditions which are created, which are very helpful for the plants to grow. Okay, some of the plants really grow very dense. Now, in the process, some plants are stressed, and herbivory, that is when insects feed on such plants, such stressed plants are removed, and then this increases the diversity. Other kinds of plants, diverse plant systems come up, and this also stimulates nutrient cycling. Now, when insects feed, the plants are converted to frass, and the frass gets mingled with the soil, and the quality of the soil also improves. So it is said that herbivores not only feed on the plants, they can play a very important role in above ground and below ground nitrogen fluxes. Now, to speak about decomposition, there is a very interesting statement which is made, which says the earth would be one global ball of dung if it weren't for the activities of dung beetles and other insects. Primarily termites and dung beetles, they are responsible for a huge agricultural service because they remove and bury the livestock dung. And thus the health of the pasture is maintained. They recycle the nutrient and make it available for the plants. Now, the dung beetle also increases the NPK, calcium, magnesium content of the soil. And also, if the dung is not removed or decomposed, there is a huge population of hematophagous flies, which cause a lot of harm to the livestock. Now, this is avoided or reduced because of the decomposition service provided by insects. Now, there's a very interesting CSIRO project in Australia, wherein there was a lot of dung which was created in certain parts of the country. Now, the existing dung beetles were not capable of decomposing. So what they did under the project was they imported certain dung beetle species which had co-evolved with the bovines and with these large herbivores. Now, these dung beetle species, imported ones, were released and they were used for decomposing the dung, and thus the situation for cattle grazing, the overall health of cattle improved in Australia. Now, decomposition of the carrion is also done by insects. The caliphorid flies are the most important insects which are responsible for decomposing carrion. Now, understanding that insects are capable of decomposing, at NBAIR, my institute where I worked, my colleagues have come out with a technology of using insects to degrade kitchen waste and farm waste. Now, an insect is used for it. It's called the black soldier fly. You can see it over here. This is the black soldier fly, and this is the larval stage of the black soldier fly. Now, these detritivorous insects like the black soldier fly have microorganisms associated with them. So when they feed on the kitchen waste, the final decomposed product of the kitchen waste is actually very rich humus, which can be used in fields. Now, many startups have purchased this technology from NBAIR. The very interesting fact is that now decomposition, though it comes under the regulatory service, this is also a provisioning service because the pupae of the black soldier fly can be used as fish feed and poultry feed. So this is why the technology is in great demand amongst small startups. Now, this is my favorite and my area of research, biological control. This is a regulatory service provided by insects. And a very beautiful statement made is that biological control is an important ecosystem service in agriculture. It is undervalued till we realized it is lost. Now, there are many groups under insects, many orders, which are responsible for biological control. So, in biological control, there are three main categories, or I should say the classification is under three categories. One is conservation biological control, one is classical biological control, and the third one is augmentative biocontrol. In conservation biocontrol, what we do is, there are some natural enemies, that is insects which are beneficial, which cause the mortality of the pest insects. These we call as natural enemies. They can be parasitoids or predators. Predators, when they feed on the pest as such, like lion or a tiger, like how we call them as predators, or they can be parasitoids because they can lay their eggs on the pest insects. They multiply on the pest insects and thus cause the mortality of the pest insect. Now, these natural enemies, that is parasitoids and predators, occur in nature naturally. Now, if we follow certain steps to conserve them and allow them to do their job, there is some disturbance, please. That is called as conservation biological control, wherein we tell farmers not to use chemical pesticides and thus conserve the biocontrol agents. The second one is called the classical biological control, where when an invasive pest enters our country, none of the natural enemies which is existing in our country can control this invasive pest. Then what we have to do is we have to import an exotic natural enemy from the country of origin of the pest. This is called classical biological control. And in augmentative biocontrol, what we do is we multiply the useful insects in the insectary and release them in the field to control the pest. So these are the three types of biocontrol, which I'll be focusing on: classical biocontrol and conservation biocontrol, because we are speaking about biodiversity. Now, what is the value of biological control? It has been estimated in monetary terms in some countries. It is valued at $5.4 billion per year in USA. What is said is that in several cases, the disservices caused by insects can definitely be prevented by protecting our ecosystem, by just allowing the natural biocontrol agents to perform. When we use chemical pesticides, what we are doing in several cases is we are killing the beneficial ones, which would have otherwise controlled the pest. So in several cases, human interventions are responsible for the disservices provided by insects. Now, Karp et al. In 2013 has come out with an excellent paper. He calculated the economic benefit of natural biocontrol of coffee pests and in Costa Rica. And what he found was that by preserving the natural biocontrol agents or conserving them, the damage worth almost $75 to $310 per hectare per year could be prevented. And this benefit per plantation was equivalent to the average annual income of the Costa Rican. So you can imagine the kind of benefit. In India, I'm very proud to say there are some beautiful conservation biocontrol examples to indicate by conserving our own insects, the beneficial insects, how India could control an invasive pest. Now, what you can see here, this white pest, it is a cottony one. It is the sugarcane woolly aphid. This is an invasive pest which entered our country and damaged sugarcane in almost all the states as I have listed here. So at that time, the then director, late Dr. R.J. Ravindra of my institute, he traveled to the northeastern states and he was in Jorat in a guest house and he was just observing some of the plants around, and on a sugarcane plant, surprisingly, he found this particular insect, Encarsia flavoscutalum, parasitizing the sugarcane woolly aphid. So he brought this parasitoid to Bangalore, and the parasitoid was multiplied within our campus on sugarcane plants. And this parasitoid in sufficient numbers were distributed to different states in our country through the agriculture department. And what happened was, when the farmers were requested not to spray, and when this parasitoid was released, automatically some other predators also were conserved because chemical pesticides were not used and the pest population drastically reduced. And this has been reported to save more than 1,000 crore Indian rupees through this conservation biocontrol effort. Now, this is one example for classical biological control. That is, when the papaya mealybug entered our country, you can see the kind of damage this mealybug caused in our country. 3 parasitoids were imported: Esophagus papayae, Pseudoleptomastix mexicana, and Anagyrus loci. Now, out of these 3, this particular one, that is Esophagus papayae, was most effective, and this was released into the fields, and it totally controlled the pest, and the savings to farmers was more than 1,500 crore Indian rupees. Now, this is a very recent example which I wanted to share. A pest which is called Spodoptera frugiperda, and the common name is fall armyworm. We call it fall. It entered our country and started damaging maize. So my colleagues at NBAIR, when they surveyed, they were not only looking at the damage which was created, they were also looking for natural enemies. Is there any insect which is feeding or parasitizing this pest and which can be used for controlling the pest? Now, as you can see, several parasitoids and predators were recorded within our country when this invasive pest entered. So here is one paper by Gardner et al., where he speaks about the value of native predators, our indigenous predators, against a single invasive pest, which was the soybean aphid in US. Similar situation we had to face when a pest entered, but we were lucky to record a whole lot of natural enemies, wonderful, indigenous, beneficial parasitoids and predators, which could be used to create an IPM module focusing on using beneficial insects and reducing chemical insecticides. I'm happy to say we could share this as a case study from India in the CIMIT IPM publication as the biological control for fall armyworm management in Asia, case study India. And also we came up with a bulletin which was called Attempts to Rub the Paw Marks of Fall Sans Chemicals. Now, there are certain points to ponder in the science of biocontrol. See, generally, when we look at the ecosystem services, we are only focusing on the yield in monetary terms, whereas we are not valuing or looking at the value of biocontrol for farmers. See, he is not exposed to chemical insecticides. His family is not exposed to chemical insecticides. So besides the fact that the amount spent on, the money spent on chemical pesticides is reduced, other than that, his exposure to harmful chemical pesticide is reduced. Also, I think there should be a clear focus on the ecological processes in biocontrol, because when we are trying to control a pest using biological control, we are not using chemical insecticides. In the process, several other useful, beneficial insects are getting protected. Now, even when you calculate the benefit-cost ratio, you generally look at the cost involved in labor, materials, etc., and the benefit in terms of reduction in pest impact, or the expenses you would have undergone if you had used some other control tactic. And they say that if the best benefit cost ratio is more than 1, it is a classical successful case of biological control. However, never ever the benefit to the ecosystem is quantified. That is never done. And that is the need of the hour. Now, coming to a light portion, that is the cultural service provided by insects. They provide religious, artistic, recreational, and other kinds of services. Now, like hiking, camping, education, and scientific, all this, there are people who, enjoy watching the behavior of insects, the aggregation of insects. Whereas it is said that insects are also symbols in religions, and they can be cultural icons too. Now, they are also important in tourist destinations. For example, the overwintering aggregating populations of the monarch butterfly, that is Donos flexibus, is considered to be a tourist attraction. And in tropical Asia, there are several butterfly houses, which is extremely popular as a tourist attraction. I think even in Singapore, in the airport, it is there. Now, the role of insects in mythology, this is very interesting. It was found in Tutankhamun's tomb, which was the only tomb which could be, observed intact in spite of millions of years. And it was found that on the mummified body of Tutankhamun, there was a scarab beetle. They felt this is a mystery. Now, two researchers, that is Theakston and Dupree, they solved the mystery because they found that it is considered to be a lucky charm, which is placed on the heart to protect the heart on its journey to afterlife. Even in Christian tradition, the bee is considered to be the emblem of Christ, for his forgiveness, for his justice. And bees are also related to the Christian virtues because of the way the worker bees behave towards their queen. So there is a lot of importance of insects in the Christian tradition, and also in the Hindu religion. Brahmara Devi is considered the goddess of black bees and one aspect of Devi. A very interesting paper by Cherry and Sandhu in American Entomologists, which says musings, insects in religions of India. Music is also inspired by insects in Western music, right from the old classical music to opera, music and opera, to the recent ragtime and pop. Insects are known to inspire music. There's the Blackfly song composed by Wade Ainsworth in 1949, as early as 1949, to the latest six-limbed drummer by David De La Haye in 2022. Now, in Indian music, there is no compilation, but because I'm a lover of music, I was just looking at songs which are inspired by insects. Bamra Bada Nadan Hai in Hindi, Tumbiva Tumba Kudathina Tunjatta Yunyalidam in Malayalam, and Poovil Wonder Modum in Tamil, and Who in the Huvike Haduva Dumbi, Enanu Hadutite in Kannada. There are many more. It would be wonderful if someone could compile this. Now, a paper by Macadam and Stockham in 2015, he says more than just fish food, ecosystem services provided by freshwater insects in ecological entomology. Very interestingly, he says that the stonefly, it has a drumming feature, and this it does in its main location strategy. Now, the authors say that this has inspired musicians, the drumming features of stoneflies. And also he has given examples of some music outfits which are named after insects. Examples, the North Carolina rock band is called Mayflies. The French band is called Mayfly Symphony Orchestra. And there's a Croatian band which is called Dragonfly. Now, I think now you can decide whether these insects, with all that I have told, the provisioning services, regulating services, supporting services, and cultural services, I think we can say that they are significant and not insignificant little things. Now, are we losing them? It is said that climate change, invasive species, pollution, all these factors are leading to the drastic reduction in our biodiversity. And it is predicted that at the current rate, 40% of the world's insects would be lost within a few decades. And Buchanan, in his 2021 paper, he says that in Germany, there was a 75% decrease in flying insects. And Siebold in 2019, a recent paper, he says that very clear evidences are there on drastic reduction in both insect biomass and also the number of species of insects. Now, I would call this the death of unsung heroes because, based on whatever I have presented, we know the kind of services which are provided by insects, and they are being just wiped out from the universe. Aren't they unsung heroes? Now, in US, the number of managed honeybee colonies have dropped by 50%. And in Germany, more than 75% of insect biomass has reduced across 63 nature areas. And a world report of 2014 says a 45% drop in the abundance of insects, and majority of this belongs to, though the summary is on invertebrates, a large chunk is about insects. The number of widespread butterfly species fell by 58%. And about bees in Oklahoma, there was a report in 1949 where they had quantified the bumblebee population. Again, they quantified the bumblebee population in 2013, and they found that only 50% existed in 2013. And also, there is a 49% decline in beetles, especially dung beetles, and I have told you the importance of dung beetles. Now, we speak about climate change and invasive species as responsible for the death of these unsung heroes. But is it only the climate change or other factors, or are we responsible, the human interventions, responsible for the death of the unsung heroes? I may even call the death of unnamed heroes, because many of them have not been identified to, but already they have left the universe. Now, saving these significant things, who save the planet? Now, first and foremost, we lack an inventory. We do not know how many insects are existing, how many are extinct, how many are endangered, and several are nameless. Now, the available literature, it does not provide any experimental or quantitative results. We just say in percentages. And most of the studies are focusing on pollinators, decomposers, or biocontrol agents. There are many more. You can see from this graph, the pie chart, that the focus is mostly on few services and not all. Now, in his book, E.O. Wilson, in his book, which is interestingly called Half Earth, he says the sixth extinction of most species of the planet, it can definitely be reversed if environmental degradation is halted. And if this has to be halted, he says half the planet has to be set aside for non-human species. He says half Earth is the only answer where we can prevent the sixth extinction. Now, first and foremost, what we have to do is to understand the diversity and the potential loss of diversity. So in his paper, Kremen and Osfeld 2005, the title of the paper says, A Call to Ecologists, Measuring, Analyzing and Managing Ecosystem Services. And that is what we have to do. As researchers, we should measure, analyze, and managing has to be done by not only researchers, by even the community has to play a role in managing the ecosystem services. Now, IUCN, the International Union for Conservation of Nature, has come out with a red data book. And in the red list, it speaks about the threatened and endangered species. They have a list. Now, surprisingly, from India, only 2 species have been included, which is strange because this is because there isn't enough work. It has not been, we do not have the data on which are the extinct species or which are the threatened species. But one encouraging fact is that the Grasshopper Specialist Group of the International Union for Conservation of Nature, IUCN, has initiated the red list assessment of grasshoppers in India. At least one group, there is a focus on understanding. Now, how can we take steps to encourage the ecosystem services? Now, this is a work done by my former colleague, Dr. Amala, very interesting work. How in situ conservation of pollinators can be done. See, either we should protect the pollinators from pesticides, or we should create an environment through providing pollen sources or nesting sites or water source to see that the pollinators will thrive. Now, there is a concept that we can have pollinator gardens where you can have pollinator-friendly plants, non-crop plants, which can attract and sustain the pollinators. Now, one such pollinator garden is there in NBAIR, where there are almost 300 species of flora, thanks to Dr. Shivalinga Swami. And this work by Amala, she studied the nesting behavior of megachiral bees. And see, this is the kind of artificial trap nest that she created. And this was set up in the pigeon pea field. And you can see that by setting up these artificial trap nests, the percent pod set increased in the treated plot. The number of seeds per pod, there was a significant increase compared to the control plot. And also the seed weight, there was a tremendous increase in the pigeon pea field where the trap nests were set up. Also, these trap nests served as home for some predatory wasps as well, which could feed on all these insects in the field. So it was a dual purpose to encourage pollinators and also to encourage predators to control the pest. Now, this is a habitat management strategy developed by AICRP in East Africa. This is called the push-pull strategy. They call it an agricultural innovation. This was for managing the fall amoeba. The strategy is that the field, maize field, is surrounded by a boundary crop that is brachiaria, which will pull the insect towards it. It is a trap crop. And there is desmodium in between the maize, rows of maize plants, which is known to attract only the natural enemies, but will push the pest. So this is called the push-pull strategy. Now, by saving the little ones, are we saving ourselves? Let's have a look. Now, a community science initiative was taken up. And here, the focus was on painted lady butterflies. This scientific name is Vanessa Cordova. Now, this particular butterfly, it plays a very vital role in ecosystem because it moves from flower to flower and it and transfers its pollen and facilitates reproduction and genetic diversity. Now, to understand which are the plants which provide the nectar source for this butterfly, a community science initiative was taken up. And through this effort, on the iNaturalist platform, 329 different nectaring plant species were identified, out of which 195 had not been identified earlier. So it's important to identify which are the plants which are attractive to insects so that you can encourage the growing of such plants. Now, this is a beautiful initiative in the city of Melbourne. It's a paper by Mata et al. 2016. It's titled "The Little Things That Run the City: Insect Ecology, Biodiversity and Conservation in the City of Melbourne." Now, here, the aim was to conserve insects and other invertebrates in the urban environment, and they had taken a huge area under this initiative. Now, they prepared a detailed inventory of all the native and non-native species and the diversity. They quantified the common species, their habitat, etc. But most importantly, they tried to provide information on the ecosystem service provided by each of the species and what management actions should be prioritized and which plant species should be conserved. All this information they generated. I think this should be a model which should be emulated by the researchers in our country. Now, this is an encouraging fact that India's nature beetle mania. This is an event which was taken up, the first kind of this kind, to encourage interest in beetles among nature enthusiasts and students and historians in India. It was a 7-day event where it involved 173 observers and 83 identifiers. So the work they did was, the exercise was, they were observing for beetles and they were submitted under this program. And the encouraging fact was that Karnataka, Uttarakhand and West Bengal were the top 3 contributors who provided information on beetle observations, and I hope more such events would occur in our country. Now, very beautiful restoration schemes have been taken up in some countries, which is an eye-opener. For the large blue butterfly, which had become extinct in Europe, in 1979, a project was initiated. They introduced this particular blue butterfly in the form of caterpillar from Sweden. And they had imported in 1983, but then the population in real large numbers were observed only in June 2022. But then right now, a huge concentration of this large blue butterfly is existing in Europe, and all due to the restoration scheme. And a beautiful...
Dr. Chandish, your
yes.
presentation went off the screen and
Oh.
there is an...
No, sir, it is fine. I can see.
It is okay. It is okay.
Yes,
Oh,
it's fine, sir.
Maybe for Dr. Angadi, there is some network issue.
Yeah, could be.
Yeah. Shall I go ahead or?
Please.
Yes.
Sir.
Yeah. So one more interesting community funded project was taken up in Sussex, wherein, they call the bees the ecosystem engineers, beautiful name for bees. And they planted wildlife corridors. They call it a road system to help the ecosystem engineers to move from one landscape to another. And by doing this, they got some funding from even the residents, and there was a 72% increase in the bee population. Now, another organization, the Center for Biological Diversity, and this is very important because they are trying to secure a future for all the species, let it be great or small. And they are running a campaign called the Saving the Insects campaign. And this center, what they are doing is they are combining science with policies. So they are trying to craft and pushing certain policies which will limit the use of toxic pesticides. And they are trying to promote certain practices which can protect insects. Now, they are also preparing very comprehensive reports which they are sharing with the public and policymakers, so that there is a general awareness created regarding the status of insects and what all are the threats they face, and what policymakers should understand in order to provide funding for projects initiated to conserve insects. Now, some of the take-home messages based on my thoughts on this topic. I think insects and other invertebrates deserve as much importance as vertebrate conservation. So the protocols, strong protocols, if they have been developed for vertebrate conservation, similar protocols should be developed for insects too. And it's a fact that in situ and ex situ conservation of insects, it's practicable and it's not very expensive. We should measure the biodiversity first and foremost. A complete inventory for the insect species on Earth, specifically in India, has to be created. And there's something called star species. See, if certain insects are available in habitats which are threatened, the insects are there, but the habitats are threatened, such species are called the star species. For example, the prairie sphinx moth is considered a star species in central states, and in the birdwing butterfly in New Guinea. But we do not have a list of Indian star species, which is important. We should quantify the species which we have lost, which I do not know how we'll do it. And we should quantify which are the species which are on the brink of extinction, so that we can take up efforts to save them. And we should understand the importance of ecosystem service, not only to environment, but also to humanity. What are the societal processes underlying ecosystem services? Most importantly, there should be monetary evaluation of the ecosystem services. Only then we can convince policymakers regarding the importance of conserving insects. Creation of pollinator gardens. This is taken up widely in other countries. Pollinator gardens or urban pollinator gardens in the middle of cities too. And visibility to the approach should be created by taking up demonstration plots where policymakers and general public should be invited to have a look at the benefits of ecosystem services provided by insects. Funding should be provided not only to measure insect diversity, but also to support insect museums, to support live insect repositories, and to projects which are trying to develop new and innovative conservation strategies. And for any work on biodiversity, national and international networking is a must. And any land management decision should be developed only by considering the ecosystem services provided by insects. And there should be a recovery plan for the endangered species, not only for the endangered species. Even the taxonomy profession is getting endangered. We should have a plan for, trying to see that more entomologists take up the taxonomy profession, because it's important to identify our insect diversity. There are very few taxonomists in our country. And there should be a sustainable plan to sustain conservation, also biocontrol strategy, which will indirectly help us to sustain our diversity. This is a 2023 publication from Royal Entomological Society, Insects in Green Spaces. Beautiful. I have a soft copy. If anyone, this is one screenshot of one of the pages, wherein, they have focused on beetles like that. They have on bugs, on hymenopterans, everything. They have beautiful pictures of how the insects look like, what they do, how can you create habitat for them. And to end, I would like to say, caught between the animal and plant kingdoms, these little yet significant things motivate us to confront and evaluate our notions, reevaluate our notions, because when we understand how they behave and the way they live, insects, we should reevaluate our notions on gender, family, society, struggle, the division of labor, societal organization, and individual and collective intelligence. Now, again, to speak about bugs, when based on Dr. Angadi's intro, now these are two insects on amongst many on which I worked. Now, the one on the top is an anthochorid bug, a beneficial insect, and the one below is again a beneficial insect, Axinoschimnus rudrayahi. Now, they may look like a harmful insect, but they are not. Both are beneficial insects. And thank you again for the patient hearing and for giving me this wonderful opportunity to present my thoughts on saving insects. Thank you so much.
Thank you very much, Dr. Chandish. That was an excellent presentation. And as you can see, the compliments are pouring into the chat box. I'm sure every one of us thoroughly enjoyed your coverage of all the aspects, music, mythology, and among us is one another eminent and pioneering biocontrol person, Dr. Manjunath. Yesterday, when I mentioned to him, he said he was busy, but he didn't want to miss your talk. She said he's an excellent presenter. I want to be there. So I am now thinking why you said insignificant. Such a significant thing about insects. They can be your food. They can be your pollinators. No, I think no insects, no people, no world. And it is really alarming that they are on the verge of extinction and we are doing nothing about it. So an excellent talk. Maybe Dr. Manjunath would like to say a few things, supplement or complement what you said. Then we can take questions. Aparna, few questions.
Yes, ma'am, you can see all the applause for your talk. It's really wonderful.
Thank you,
So
sir.
as Sharan sir said, please, Manjunath sir, if you want to make any comment, please do, and then we can open the session for the discussion.
No, I have only compliments for Dr. Chandish Ballal because she has covered a wide range of insects which are beneficial to us. And as Dr. Angre mentioned, I mentioned to him that I would like to attend this because she's such a good presenter. And I have known Dr. Chandish for nearly 40 years now. She has grown in stature and in knowledge. And full compliments to you, Dr. Chandish, for making such a good coverage.
Thank you, sir. Thank you so much, sir. I'm so happy you were here. I know you're extremely busy today. I didn't expect you.
No, but I missed the initial 5 minutes because there was a problem in logging in. And I missed Dr. Ragdi's introduction, which I was very keen to attend, but I missed it. But your presentation, I fully heard and enjoyed it.
You see few raised hands, Dr. Aparna. Maybe you would like to call.
Yeah, Sharad Deshpande sir, would you like to ask the question?
No, I'll come a little later.
So now there's a Ranjit Chauhan.
Yes, ma'am.
Mr. Ranjit.
Yes. Yes, ma'am.
You raise the hand. You want to ask question?
No, ma'am, no more question. Very useful session. Thank you.
Maybe we can call others, Dilip and
Yeah,
Canada.
Dilip Verma. Mr. Dilip Verma.
Yes, myself, Dr. Dilip Kumar Verma, presently posted at IRI Indore as principal scientist. Just one thing I want to give information, one can say, or ask the question, whatever may be, to Madam Chandish Ballal. In 2-3 days back, I was going through your paper, and I was surprised that natural source of dyes or colors, is a main source is from insect. Is it so? Then how we can see this in future?
Actually, not the main source. Insects, cochineal dye
Yes,
is derived from insects. So it is a source which can be utilized for deriving dyes, But on an industrial scale, if it has to be done, a commercial unit has to take it up, considering the basic principle of extracting dyes from the cochineal insects. It's not that globally or immediately a factory scale production is possible, but then the origin of dyes can be from cochineal insect.
It was also mentioned in that paper that only that color is available with the insect only. No artificial dye is available for that. Then we are eating only that type of colored food items, particularly shining orange color.
No, I didn't get your question, sir.
My question, perception is that the color is orange, bright shining orange color, and the preparations of dishes, that dye is being used by taking the natural dye from that source. Is it so that we are not having the alternative of that dye?
I don't think so, sir. I'm not clear which paper you're talking about. Anyway, can we discuss through email also? Because I don't know which paper you're talking about.
Okay, ma'am.
Because one paper I have published with EMPRI. I don't know if you're talking about that paper, wherein I have made a mention of the contributions, which includes the fact that the dye can be extracted from the cochineal insect, the cochineal. Yeah.
Okay, ma'am. Thank you.
Please get in touch with me. I would be happy to discuss with you.
Okay.
Yeah, sure.
Ma'am, there is one person, Rana Dhi Reddy Nomula.
Okay.
It's a mail ID. You like to ask your question, Mr. Rana?
Please, Ranadhir Reddy.
Mr. Reddy? No. So maybe Sharad sir, you can ask your question.
Yeah, no question. Only a compliment to Dr. Chandish Ballal for excellent presentation you made. It was less scientific and more poetic.
Thank you, sir. Thank you, sir.
Only my concern is I have been observing that the agrochemical usage has gone up tremendously. And particularly in recent years, the use of herbicides. I don't know to what extent it has impacted on the life of the beneficial insects, what you were discussing. And especially when you were discussing about the fall armyworm in case of maize, that has caused a lot of problem for all the farmers. Earlier, no farmer was carrying a spray pump on his back when he was growing maize. Now it has become a mandatory thing for him. Okay, so how to reduce the use of these agrochemicals? That aspect, I think you did not touch upon.
Yeah. Thank you, Dr. Deshpande. Actually, when the fall armyworm entered our country, in fact, there were no chemical pesticides even which were registered and had the label claim for being used on maize. But then on an emergency basis, in order to help the farmers, that was done. Now, in the case of biocontrol, in spite of the fact that so many natural enemies were identified, a nucleopolyhedrosis virus was identified, an isolate of Metarhizium anisopliae was identified, which worked very well on fall armyworm. A BT was isolated. In spite of all this, there is a need for companies to take up this biopesticide, claim, apply for registration, only then it would be commercially available. So that is, I think Dr. Manjunath would also agree with me when we say that in spite of the fact that we have very many potential biopesticides for being used against specific pests, the fact is that commercially companies should come forward to take up the production of these biopesticides, like chemical pesticides are being produced. So this is a huge challenge, which I think researchers can only give suggestions, provide solutions, give the isolates. It is for the commercial companies to come forward and take up the production and see that the farmers get this safe alternative. And in fact, when I was in service, we had certain demonstration plots which were managed with only biocontrol agents, and we invited farmers to have a look, to tell them, see, this is working. You don't have to use chemical pesticides. But then the biocontrol agents and biopesticides should be available, especially the good quality ones. So for which there has to be a initiative from companies. In fact, I used to tell Dr. Manjunath that chemical pesticide companies should produce at least a couple of biopesticides. Only then, the science of biocontrol, because they have the facility, they have the funding, they have, the small startups are not able to afford the amount which has to be spent on generating safety toxicology data for registration. So that is one of the major issues.
Actually, this aspect is getting momentum, because a few of the major chemical manufacturing companies, now they have taken the production of biopesticides also. And also there is an organization called World Bioprotection Forum, and they are trying to bring all the industries together in order to promote the massive production of biopesticides. My concern was that, a lot of emphasis has been given for the production of microbials, but parasitoids and predators, it is not receiving as much attention it should.
Exactly.
So I've been trying to emphasize that they should give equal importance to parasitoids and predators also, about which Dr. Chandish has covered a lot in her presentation.
My small intervention here, biopesticides as of now is only of academic interest. They end up in only research papers. There is no significant use in commercial terms. Probably the chemical farming as well as the biopesticide, they don't go hand in hand. There is no knockdown effect.
No, if you take the statistics for the last 10 years, you will find that the production of biopesticides has gone up.
Yes.
It has gone up. It's actually, if you take the percentage alone, its growth is more than that of the chemical pesticides. So it is predicted that in about another 15 to 20 years, biopesticides is going to take the center stage on a global scale.
And one more point which I did not mention in my presentation, entomopathogenic nematodes are also very important biocontrol agents. There are two species, Heterorhabditis and Steiner nematodes. Now, they do not require, they are exempted from CIBR and RC registration. So some of the smaller companies are have initiated the production of entomopathogenic nematodes. Even for the fall armyworm, in our trials, they worked very well. So this is something promising, which does not have to go to the CIB-NRC registration stage, and which can reach the farmers. But again, young entrepreneurs should take up the production of some of these microbials, parasitoids and predators, and entomopathogenic nematodes. See, until this happens, it cannot reach the farmer.
Dr. Aparna, looking to the time, I think we have several questions in the chat box also that can be responded. Maybe it's difficult because I know so many hands are raised. How do you like to handle this?
Well, we can cover a few questions quickly.
Okay, please do.
Mr. Dilip is asking, the potential use of insect as a food. And I'm also wondering what would be the possibility, because Netherlands is working on this area since last 10 years. They are, they have a rigorous facilities to convert insect as a source of protein. So what do you, think to have such initiative in India?
See, in some of the states, like in the northeastern states, the local communities are already using insects for food. The edible insects are being used. In fact, in the market areas, they sell. I had put a picture of that. They sell edible insects in some of the rural areas. But then, if it has to come up in a big scale, because in US, when I went to attend an IPM conference, one of my colleagues who came to present a paper, she brought packets of chips made of insects. It's a big industry over there. But one positive thing which is happening here is using insects as poultry feed and fish feed. This, I find that there is a very good, there are people who are really wanting to take this up, especially the poultry owners and those who have fisheries. And this study we had conducted in collaboration with NIANP in Bangalore and Fisheries Institute, because if an insect we are providing as food, the safety aspects are very important. So the trial runs were done to see how safe are these insects to poultry, and along with the Fisheries Institute to find out if they are safe to fishes. So for human beings, there is a good potential, but then it has to be taken up in a big scale, like in other countries.
Yeah. Arun Agrawal is asking whether any predator for the whitefly.
For the whitefly, depends on which predator, which whitefly species. See, in the last thank you slide, I had put the image of a little beetle. That is Axinoschimnus puttarudrai. It is a whitefly predator. Now, in nature, we find it feeding on whiteflies. Now, for the coconut rugospiraling whitefly, there is a parasitoid which is there in nature. So what we generally do is such parasitoids, there's a lot of disturbance up and somebody is okay. Now, some of these parasitoids, what is being done is redistribution. From some states and some orchards, a lot of population of this parasitoid is there. That is the Encarsia flavoscutellum, which is there in not flavoscutellum, another species for rugospiraling whitefly. That occurred in some of the plantations. These are being redistributed to other places. So there are very many parasitoids, Erythmoceras, Encarsia. These are all parasitoids, but there is a hurdle in mass multiplication of Encarsia. So at this juncture, what we do is we tell farmers to see that they are conserved. If you can't produce them and release them, there is an ample option to conserve them and redistribute. Yeah, Bemisia tabaci, he's asking, Erythmoceras and Encarsia species are important parasitoids, but multiplication is a challenge. Though it is happening in some of the insectaries in other countries, especially in Australia. And one of my colleagues has been trained there with an intention that he may be able to produce at least one species in India. Because whitefly parasitoids, I want to mention here, if you have to multiply the whitefly parasitoid, you need to have a culture of the pest also. And multiplying whitefly is extremely difficult. See, other parasitoids you can multiply on alternate hosts, but then whitefly parasitoid has to be multiplied on whiteflies itself. So that's the challenge. Right now, no insectary in India is producing whitefly parasitoids. All you can do is you have to collect from nature or conserve them as they are in nature.
Arun, do you have any other question?
Yeah, Aparna, good morning. Yeah, actually, well, I was thinking that, okay, the whole of the world is like very much disturbed with the virus infection, especially like in India, we know that, okay, a lot of viruses are there. we like to control them, and this Bemisia TBSI is the major problem. So we are just sincerely looking for a easy solution for farmers, if that could be possible. So, ma'am, if like in detail again, you can put like 2-3 lines, and we can make it available to all the farmers. So it would be a generous help to all the farmers and mankind.
You can you send me a mail, Dr. Arun, because right now, as I told you, right now, Encarsia and Eretmoceres are not available commercially, but there are methods to mass rare them. And another option is you have to understand when the population is of a significant number and try to conserve them. Now, I have put up my mail in the chat box I have included. If you send a mail to me, we can have more discussions, and I can introduce you to my other colleagues in NBAIR who are currently working on whiteflies, if not specifically on Bemisia, on other species of notorious whiteflies also they are working, if that's all right with you.
Thank you. Thank you so much. I'll send you a personal mail.
Yeah, sure.
Thanks a lot.
Thank you. Thank you.
Mr. Krishna Deshmukh, would you like to ask your question?
Yes, ma'am. First of all, good afternoon. You mentioned in your conversation that black soldier fly is a beneficial insect that decomposes. So I would like to hear that. Is there any parasitoid or predator for black soldier fly?
No, there is no parasite or predator for black soldier fly because we want the black soldier fly to be multiplied and used. It is used for decomposition of the farm waste or kitchen waste, and this black soldier fly pupae are used for feeding poultry and fishes. So in fact, we are using this as a resource. So even if there is a parasitoid or predator, we wouldn't want it to thrive. We would see that black soldier fly culture is protected from parasitoids and predators. As of now, we have not recorded any parasitoid or predator of black soldier fly. Am I clear, Dr. Deshmukh?
Okay, ma'am. Okay, ma'am. Okay. Thank you.
Thank you.
So quickly, last question we can take from Mr. Kaushik Chaudhary.
Hello. Yeah, good afternoon, ma'am.
Good afternoon.
Kaushik Chaudhary this side from Gujarat. First of all, ma'am, you have delivered a great presentation regarding this insect ecology. And my question is that regarding EPN, entomopathogenic nematodes. So I want to know, ma'am, do you provide any commercial production technology training for production of these entomopathogenic nematodes?
Yes. At NB, I cannot provide. I am retired. You can contact the director of NBAIR, Dr. Sushil, and training are provided. And if the whole technology of EPN formulation is also required, it is a technology for purchase. But then the EPN technology in general, it is open for training also at NBAIR. I would be very happy if you contact Dr. Sushil and get a training so that, the more people use EPNs or any biocontrol agent, I'm the happiest.
Yes, ma'am, definitely. Okay, thank you, ma'am.
Thank you, Dr. Kaushik.
Now I request Sharan sir to please the closing remark.
Excellent. Again, I would say number of discussions, the compliments pouring in. I thoroughly enjoyed Dr. Chandish. Excellent. You covered every aspect. The music, mythology, the food. And I knew importance of bees and other pollinators. And I know there was a very interesting article I read in National Geographic, I think. Without bees, how half the world would be starving. So besides that, you made several things. I'm now wondering why you made it as insignificant bugs. They are all very, very significant. Probably wanted to bring out their significance by mentioning it as insignificant and arousing our curiosity. Thank you very much. Very great presentation. I am happy we made a big beginning with a bang this year with your presentation. Thank you. And though we call ourselves advanced training in plant breeding, we cover several aspects. And this was, as I am seeing from the compliments pouring in, This is one of the best talks we have ever had.
Thank you so much.
Thank
Thank
you.
you. Thank you very much for opportunity. Thanks, Aparna. Thank you, Dr. Sharon.
Thank
Dr. Manjunath, thank you so much.
Yeah.
Thank you, ma'am.
Aparna.
Thank you very much for joining this session. Thank you all for your presence, and looking forward to see you next month with some other exciting workshop. Have a wonderful day to all of you.
Wonderful day and Happy New Year to all of you. Thank you. Thank you very much, Dr. Manjunath, for joining despite your busy schedule today. Thank you, Dr. Chandish. Bye-bye. Bye. Good day.